Hey guys, you made it to the last one, and today we are learning how to solve logarithmic equations. Let's go. Hey guys, and welcome back. Franck here, and this is the last video on our series of 5. And if you're not done so yet, go ahead and subscribe to the channel so you can get more videos like this one. Today we are going to be focusing on solving logarithmic equations. And as you know already, solving equation is a game where the goal is to get x by itself, to isolate it. And the golden rule here is whatever you do on one side, you do on the other. Keeping in mind, of course, a reverse order of operation. So I've talked about how to solve equations already in Note 11. And so if you want a refresher on that and the reverse order of operation, go ahead and check it out. In that note, you're going to learn that addition and subtraction cancel each other out. Also, multiplication and division cancel each other out. And finally, that root and power cancel each other out. In this particular video, you're going to learn something new, and that's the fact that exponential cancel log. And if you come from my note 47, where I talked about properties of logarithmic function in details, you know what I'm talking about. When it comes to logarithmic equations, there's one more thing that you should be worrying about, and that's the fact that the base log function's domain is from 0 to infinity. What that means is you can't have negative number inside a log function. You should only have strictly positive number. So even 0 is not included. All right, so let's go ahead and jump into some examples so I can show you how this plays out. So my first example here is going to be the log base 4 of x equals to 3. And so here, since the log is base 4 and it's holding x hostage, to free x from the log, I need to go ahead and exponentiate both sides because the exponent cancel log. And so if I go ahead and exponentiate both sides, I'm going to have here 4 to the exponent of log base 4 of x equals to 4 to the exponent of 3. And so 4 and log 4 here are going to cancel each other. And what you're going to have left is going to be just x. And that should be equal to 4 cubed, which happens to be 64. And so in this case, our answer is x equals 64. And one thing that we should do, of course, always is to check if this answer actually works out for our log, right? So when you plug this answer into your original equation, would the log be holding a negative number or would it be holding a positive number? In the case it's holding a negative number, this answer should be thrown away because it's extraneous. But in the case where it's holding a positive number, this answer should be good. And so since the log function here is only holding x, and our answer here happens to be x equals 64, which is strictly positive, we would go ahead and keep it because it's not extraneous. All right, let's look at the next example. So I'm going to have here 5 ln of 2x equals to 20. So of course here, x is still hostage because it's held by the natural log. But here, I cannot go ahead and exponentiate both sides. And the reason why is because there's still a 5 in front of the ln. So I have to first get rid of that because we are following reverse order of operation here. And so the first thing I'm going to do here is divide both sides by 5. And so that's going to give me ln of 2x because the 5 are going to cancel. And on the other side, 20 divided by 5 would give me 4. Now that ln is by itself, I can go ahead and exponentiate both sides. So I'm going to have e to the power of ln of 2x equals to e to the power of 4. And so e and ln cancel each other out. And so now you can go ahead and divide both sides by 2 to get rid of the 2 next to the x. And what you're going to get at the end is x equals to e to the power of 4 divided by 2. And so as you can see here, if you plug in this x value into our ln, because the x value is positive, the ln will be holding a positive number. And so this answer will be good. All right, so my third example here is going to be 3 log x equals to log of 125. And so here, I still have a 3 next to the log, and so I cannot go ahead and exponentiate both sides yet. I need to get rid of the 3 so that I can have the log by itself. But notice here that something that's different from the last example is the fact that there's log on both sides. So if you were to divide both sides by 3 here, it will just move the coefficient 3 on the other side, making it a 1/3, and then we would have the same problem. And so in this case, I need to find a different way of getting rid of this 3 in order to exponentiate both sides. Luckily, we have the properties of log that we learned in Note 47. So if you want to refresh on that, go ahead and check that out. But what we need from that is the power property, which simply says that if you have a number next to the log, you can bring it in as a power. And so here I'm going to go ahead and carry this 3 and put it as a power to the x variable. And so that's going to give me log of x to the power of 3 equals to log of 125. So now I have log by themselves. I can go ahead and exponentiate both sides. In this case, the base of my exponent will be 10. And so exponentiating both sides by 10 here would cancel out the log. Or I can just go ahead and cancel out the log directly since they have the same base as a shortcut. And so that's going to give me x cubed equals to 125. And if you take the cube root on both sides, you should get x equals to 5. And of course, this 5 here is a good answer because the only condition we need for x here is for x to be positive. All right, so next example, I'm going to have ln of the square root of x plus 3 equals to 1. Okay, because ln is holding something complex here, I'm just going to go ahead and decide here and keep in mind that the expression under the root here should be bigger than 0, which means that the x that I'm looking for should be bigger than negative 3. All right, let's go ahead and get started. And so, since my ln here is already isolated, all I have to do here is exponentiate both sides by e. And so putting e on both sides here is going to cancel out the ln on one side. And so you're going to get the square root of x plus 3 equals to e, because e to the power of 1 here is just e. And so with that, to get rid of the root, I'm going to have to do power of 2 on both sides. That's going to give me x plus 3 equals to e squared. And then finally, I'm going to have to take 3 from both sides. And so that's going to give me x equals to e squared minus 3. And so in this case now, we have to make sure that this particular answer is bigger than negative 3. And so since e is a number that's approximately equal to 2.72, we can be certain that e squared is bigger than 4, which means that e squared minus 3 is bigger than 1, i.e. it's a positive number. And so since our condition requires for x to be bigger than negative 3, this will be largely sufficient and will be done. All right, so let's go ahead and look at 2 more examples that are slightly more difficult. Our next one is going to be log base 5 of x plus log base 5 of 4x minus 1 in parentheses equals to 1. Since I have 2 different logs here, I'm just going to go ahead and write out what my condition for x should be. And so from the first log, I want x to be positive, and from the second log, I want 4x minus 1 to be positive as well, which means if I solve for x here, I will want x to be bigger than 1 divided by 4. And so in this case, I have 2 different conditions. I have that x should be bigger than 0, and also x should be bigger than 1 over 4. And so if I merge these 2 conditions together, I would have that x should be bigger than 1 over 4. And that's the one I'm going to keep in mind because it includes the other one. And so now I can go ahead and get started. Since I have 2 logs here, again, I'm going to have to use the properties that we learned in note 47 to merge these 2 logs into 1 log so I can exponentiate both sides. And so since here I have an addition, that's going to be the product property. And so I'm going to go ahead and write this as log base 5 of x multiplied by 4x minus 1 altogether equals to 1. And so now that I have only 1 log present, I can go ahead and exponentiate both sides by 5. And so 5 and log base 5 here are going to cancel. So I'm going to have on this side, if I multiply x by 4x minus 1, it's going to give me 4x squared minus x. And on the other side, since I have 5 to the power of 1, that's just going to give me 5. And so bringing it on the other side will give me negative 5. And all of this will be equal to 0. All right, so at this point, we have to go ahead and factor out this quadratic. And since the coefficient of x squared is not equal to 1, this is going to be a little bit more complex than what we're used to. So if you need a refresher on how to factor quadratic, I suggest you go ahead and check out note 6, where I talk about that in detail. So in this case, I'm looking for 2 numbers that are adding to negative 1, but multiply to AC, which is 4 times negative 5, which means negative 20. So in this case, my 2 numbers are going to be 4 and negative 5, but since a, the coefficient of x squared, was not 1, in this case, I'm going to have to go ahead and divide those 2 numbers by that coefficient. And so that's going to give me 4 over 4 and negative 5 over 4. Simplifying them to the lowest form is going to give me on the first one here, 1 over 1, and on the second one, negative 5 over 4. And so now I know that the numerators on these fractions are going to be my constant, and the denominators are going to be my coefficient. So I'm going to go ahead and write my factor as x plus 1 coming from the first fraction and 4x minus 5 coming from the second fraction equals to 0. And so with that, I can go ahead and set each of those factors equal to 0. I will get from the first factor, x equals to negative 1, and on the second factor, x equals to 5 over 4. And of course here, since our condition requires for x to be bigger than 1 over 4, x equals to negative 1 is going to be cancelled out. And so our only solution here is simply going to be x equals to 5 over 4. And we are done. All right, so let me give you the final example that's also a little bit tricky. We're going to have here ln of x minus 4 plus ln of x plus 1 equals to ln of x minus 8. So in this case, our conditions here are going to be that from the first log, we want x to be bigger than 4. From the second log, we want x to be bigger than negative 1. And from the third log, we want x to be bigger than 8. And so if you combine all these conditions, you will want x to be bigger than 8 because that includes all the other two conditions. And so we're going to keep that in mind as we're solving this equation. All right, so again, on the left side here, we have two different logs. So we're going to have to use the product properties of log to make it into one log. And so that's going to be ln of x minus 4 multiplied by x plus 1 equals to ln of x minus 8. And so now we can go ahead and exponentiate both sides by putting e on both sides, or basically just canceling out the ln. And so that's going to give us on the left side here, x minus 4 multiplied by x plus 1 equals to x minus 8. Now multiplying everything will give us x times x is x squared, and then x times 1 and minus 4 times x is going to give us negative 3x. And finally, negative 4 times 1 is going to give us negative 4. Bringing out the other expressions on the other side as well will give us negative x plus 8 equals to 0. Now we can go ahead and combine all these. So we're going to get x squared minus 4x plus 4 equals to 0. And of course, factoring this out, we are looking for two numbers that are adding up to negative 4, but multiplying to 4. This is going to be negative 2 and negative 2. And so we're going to have here x minus 2 squared equals to 0. And that's going to give us that x equals to 2. And so in our case here, if you look at our condition, we would like for x to be bigger than 8. And so since x here is equal to 2, that's going to be an extraneous solution because it's out of the domain. And so the answer for this particular equation is going to be that we have no real solution. And so with that, we are done. And so as usual, if you would like a copy of this particular note, check out the descriptions below. And if you would like to get my future videos, don't forget to subscribe. Finally, if you like the way I break down the material, give me a thumbs up and I'll see you next time. Bye-bye.